The third step is formation of clot. Now I'll explain you how fibrin clot is formed. See, this is the blood vessel. This is the injured area. This injured area is covered by platelet plug, by activated platelets. So these are all activated platelets. When the platelets are activated, their glycoprotein 2b3A receptors are activated, and also the surface will have negative charge. The surface of the platelets are negatively charged. Now we need to understand how clot is formed. So what do you mean by clot? Clot is nothing but a fibrin meshwork that is trapping the platelets, RBCs and WBCs. So all the blood cells are trapped in fibrin meshwork. So consider this is the fibrin meshwork, and within the fibrin meshwork, different cells are trapped. Different cells are trapped to form a semi-solid mass. Semi-solid mass, that is clot. So clot will have fibrin meshwork and all the blood cells. So the clot can be formed by activation of coagulation factors or clotting factors. What are these clotting factors? They are plasma proteins. They are synthesized mainly from the liver, except factor 3, factor 4. The clotting factors are given by Roman numbers. They are from factor 13 to factor 1, or you can keep it as factor 1 to factor 13. So these clotting factors are mainly synthesized from the liver, except factor 3, factor 4. Factor 3 is the tissue factor and factor 4 is the calcium ions. So this tissue factor is nothing but consider this is a cell, and this cell membrane protein along with the phospholipids, this forms a tissue factor, and this tissue factor, glycoproteins and phospholipids are present over the fibroblast cells. Fibroblasts, they are also present over the cell membrane of vascular smooth muscles. So whenever there is damage to the blood vessel wall, the connective tissue fibroblasts which are present in the connective tissue, subendothelial connective tissue, these fibroblast cells, the cell membrane is broken into fragments, and also the smooth muscles which are present in the tunica media, these smooth muscles will have the tissue factor. So smooth muscles also will have the tissue factor. So when there is injury to the vessel wall, these are all broken down into small fragments and these are released into the circulation. So the tissue factor will be released into the circulation. So this is a small fragment of cell membrane with tissue factor. So I'll write here one more. The small fragment of cell membrane of fibroblast cells are the vascular smooth muscle cells and the tissue factor. So tissue factor is from the tissues, the fibroblasts and the vascular smooth muscles. That is the factor 3. Factor 4 is calcium. The remaining factors 1, 2, 5 to 13 are synthesized from the liver. In circulation, these clotting factors, the proteins are in inactive form. So these clotting factors in circulation are in inactive form. These clotting factors gets activated only after there is injury, or they also can get activated when the blood taken out and placed in the test tube. So the clotting factors gets activated and the clot is formed in the test tube. But within the body, in circulation, the clotting factors are kept inactive and there is no formation of clot in healthy person without any damage to the vessel wall. Only when there is damage to the vessel wall, the clotting factors will get activated. So there are two ways how these clotting factors are getting activated, two pathways, intrinsic pathway and extrinsic pathway. Now let me explain you the two pathways how these clotting factors are getting activated, finally resulting in formation of fibrin threads. The intrinsic pathway, also called contact activation pathway, so in this intrinsic pathway or contact activation pathway, the first clotting factor to get activated is factor 12. Factor 12 is also called contact factor or Hegeman's factor. So this factor 12, when it comes in contact with the negatively charged surface of the platelets, it gets activated. So the reason for activation of factor 12 is when this factor 12 comes in contact with the negatively charged surface of the platelets. So I'll just write it here, factor 12 is getting activated. So when this factor 12 here comes in contact with the activated platelets, the surface of the activated platelets. So that is why factor 12 is called contact factor. And once this contact factor is activated, this will cause conversion of prekallikrein to kallikrein. So this prekallikrein is a protein present in the plasma. This will be converted into kallikrein by this activated factor 12. And once this prekallikrein is converted into kallikrein, this will cause further activation of factor 12, amplifying this activation. This is like a positive feedback, amplifying and increasing factor 12 activation. More and more factor 12 gets activated by this positive feedback mechanism. And there is something called high molecular weight kininogen. So this high molecular weight kininogen is a protein that is secreted from the platelets over the surface of the platelets. This will act as a anchoring holding the factor 12 to the surface of the platelets. Let me explain by elaborating the surface of the platelets. See, this is all happening over the surface of the platelet. Consider this is a big platelet. On the surface, it is negatively charged. So this factor 12 comes and binds to the platelet, and there is called high molecular weight kininogen. This HMW kininogen acts as some anchoring adhesion molecule so that the factor 12 binds to the platelet and this will get activated. Factor 12 gets activated over the surface of the platelet. Once this factor 12 is getting activated, this will activate the prekallikrein. Prekallikrein is getting activated to kallikrein, and this kallikrein will further activate more and more factor 12. So this is the first step in intrinsic pathway, activation of factor 12. So once factor 12 is activated, the next is this factor 12 starts activating the subsequent clotting factor. Next clotting factor, that is factor 11, is getting activated. 12 activates 11. 11 activates 9. So this 11 is activating 9, not the 10. So now this 9 activated will combine with factor 8, which is activated by thrombin actually. Factor 8, which is activated by factor 2A, thrombin, and this factor 9 along with factor 8, they form complex along with calcium over the platelet membrane. So this is all forming a complex over the platelet membrane, phospholipids, binding to phospholipids. So the cell membrane is made up of lipid bilayer. So now this is a complex. This is a complex, factor 9, factor 8, calcium and phospholipids of the platelets. This complex will activate factor 10. So this will activate factor 10. 10 is converted into activated factor 10. So 9 is activating factor 10. Now once this factor 10 is activated, this will activate the prothrombin factor 2 factor activated factor thrombin. So prothrombin is converted to thrombin. Once thrombin is formed, thrombin will act on the factor 1 fibrinogen to break down into fibrin. Fibrin monomer. Once fibrin is formed, see, fibrin is a 3-nodular structure. This fibrin monomer 3-nodular structure, trinodular structure, will organize so that all these will form a chain. So we can call this as polymer of fibrin, polymerization of fibrin. So like this, the chains are formed. So this is one fibrin monomer. Like this, all the fibrin monomers will form a chain. So this chain individually, this is a fibrin thread. So this is also one fibrin thread. So like this, many fibrin threads will be formed. Fibrin strands or fibrin threads will be formed. And now this factor prothrombin converted to thrombin, this thrombin 2A activated, this also will activate factor 13. Factor 13 is the fibrin stabilizing factor. This fibrin stabilizing factor will form a cross links between these strands, so that the clot which is formed, the fibrin meshwork that is formed, will be very tough now because of this cross linkages. And calcium is a cofactor along with factor 13 in cross linkages. So this is how the fibrin meshwork is formed by intrinsic pathway. So to summarize the intrinsic pathway, it starts from activation of factor 12. Activated factor 12 will activate factor 11. Activated factor 11 will activate factor 9. This 9 forms a complex with 8 along with calcium. It will activate, this 9 will activate 10. So once the 10 is activated, the 10 will form a complex with 5 and calcium and membrane of platelets, the phospholipid membrane. So this forms a complex. This complex will activate the factor 2. So once factor 2 is activated, it will activate factor 1 to form fibrin meshwork. So here also, this activated factor 9 forms a complex with 8 calcium and also membrane phospholipids. So this is all happening over the surface of the platelets. Factor 12 is getting activated by contact with the activated platelets. This will activate 11. 11 will activate 9. 9 forms a complex with activated 8 calcium over the membrane of the platelet binding to the phospholipids, cell membrane phospholipids will activate. 9 will activate 10 with all this complex. 10 is activated. 10 activated will form a complex with 5 calcium, and over the membrane of the platelet phospholipids it will activate 2. Once 2 is activated, that is prothrombin is converted into thrombin. Thrombin will convert the fibrinogen to fibrin. This fibrin stabilizing factor, factor 13, not only forming the cross link between the two strands, this also links the fibrin monomers together by covalent bonds. So this is how the fibrin monomers are also linked together by covalent bonds. So this linking is by the factor 13, fibrin stabilizing factor. So this fibrin stabilizing factor gives stability to the fibrin clot. So the final formed clot is a stable clot which is very tough. It cannot be ruptured so easily. So and also cross linking I will show here. So this is like cross linking between the threads. So this is how between the threads also cross linked, and also between the fibrin monomers also the covalent bonds are formed. So to summarize the intrinsic pathway or contact activation pathway, the factor 12 gets activated. This factor 12 activation is because of the contact of this factor 12 with the negatively charged surface of activated platelets. And this once factor 12 is getting activated, this will convert the pre-kallikrein to kallikrein, and this kallikrein will further activate more and more factor 12. Also this factor 12 will activate factor 11. Activated factor 11 will activate factor 9. Activated factor 9 will form a complex with factor 8 activated calcium on the surface of the platelet phospholipids. So this is the complex. This complex will activate factor 10 to activated factor 10. This factor 10 activated will activate factor 2. For the activation of factor 2, this activated factor will combine with activated factor 5. So this activated factor 5 along with calcium over the surface of the platelets, so binding to the platelet phospholipids. So these are the platelet phospholipids. So this complex will activate the factor 2. Factor 2 is prothrombin. Activated factor 2 is thrombin. So once factor 2 is activated, this will activate fibrinogen or convert the fibrinogen to fibrin, and fibrin monomers autopolymerize to form fibrin threads, and activated factor 13, that is activated from factor 2 thrombin will activate factor 13. This activated factor 13 will cause cross linkage of fibrin threads to form a stable clot. Finally clot is formed, that is a stable clot formed, and calcium is a cofactor required for formation of stable clot. See, this thrombin has a role in activation of 5A. Thrombin also has a role in activation of this 8. Thrombin has a role in auto activation of more and more prothrombin to convert into thrombin. So thrombin, which is factor 2A, can cause auto activation of factor 2 more and more. This can activate 13. This will activate or convert fibrinogen to fibrin. fibrinogen to fibrin. Fibrinogen is factor 1. So factor 2 thrombin will activate factor 13, factor 1 auto activation, and also it can activate the upstream factor 8 to factor activated factor 8 and also factor 5. And also this thrombin has a role in activation of platelets also. And once more and more platelets are activated, these platelets acts as a surface on which the clotting factors can bind and get activated and amplifying the formation of clot. So thrombin has very important role. Thrombin, factor 2A is thrombin. Now let us see how this extrinsic pathway is getting activated. Extrinsic pathway, see, extrinsic pathway is also called tissue factor pathway. What do you mean by this tissue factor? Tissue factor is a molecule present over the membrane of fibroblasts and also the vascular smooth muscles. See, this is the fragment of membrane of vascular smooth muscle, and this is the tissue factor. Tissue factor, protein and phospholipid complex. So how this is released into the circulation? Whenever there is injury to the vessel wall, the fibroblasts are also split, damaged. The vascular smooth muscles membrane is also fragmented. The damaged fibroblasts and damaged smooth muscles membrane fragments are released into the circulation. So this will have the tissue factor. And once the factor 7 comes in contact with this tissue factor, tissue factor is also a clotting factor. Tissue factor is factor 3. Tissue factor is factor 3. So factor 7 coming in contact with tissue factor, this gets activated. Now this factor 7 is bound to tissue factor. Factor 7, tissue factor along with calcium. This forms a complex. All this together can activate factor 10. So once factor 10 is activated, this factor 10 will combine with activated factor 5 calcium over the membrane of platelets binding to the platelet phospholipids, will activate prothrombin to thrombin, and the cascade continues similar to that of the intrinsic pathway. So to summarize, intrinsic pathway starts with activation of factor 12, activating the factor 11. 10 is not activated, 10 will be activated later. Here 11 will activate 9, 9 will form a complex with 8 calcium on the phospholipid membrane to activate 10. In the extrinsic pathway, factor 3 is exposed. Factor 3 is the tissue factor. Why it is called extrinsic pathway? Tissue factor is not in the circulation. Only when there is injury to the vessel wall and the fragments of the fibroblast membrane and the smooth muscle membrane are entering into the circulation, this tissue factor will activate factor 7, and this forms a complex with calcium to activate 10. So 7 plus 3, 10. 9 will activate 10. So 10 is getting activated. Now this 10 activated will bind with 5 calcium over the platelet phospholipids, will activate factor 2. So this factor 2 will convert fibrinogen to fibrin 1. So this is the summary of intrinsic and extrinsic pathway. Now this 2, activated 2 can activate 5, can activate 8, can activate 1, can activate 13, can activate Platelets can also activation of itself. 2 is what? Factor 2 is thrombin. I hope you understood coagulation cascade. Thank you.